Alright guys, here we are with lesson 12-3, titled Angles and Arcs. We're still looking in the chapter on circles, so we're talking a lot about circles and arc measures and things of that nature, so hope you're ready to go. So, let's look at a quick vocabulary word. Inscribed angle is an angle formed by two chords with a vertex on the circle. So you've seen this term inscribed before. We've said a circle is inscribed in a square, or a triangle is inscribed in a circle, or we've seen all those things before. But it just means the vertex itself is on the circle, and the lines go through the chord like so. So this angle here would be called the inscribed angle, right? So let me give you an example of an angle that is not an inscribed angle. So if I have something like this, and it comes out of the circle like so, that would not be an inscribed angle. So it has to be formed by two chords, specifically. Okay, so this would be an inscribed angle. Alright, there's a theorem. It says, if an inscribed angle and a central angle have the same intercepted arc, then the measure of the inscribed angle is half that of the measure of the central angle. So again, let's look at this picture. So we have an inscribed angle which intercepts this arc here. So the inscribed angle intercepts that arc there that I just highlighted. We're going to look at the central angle that intercepts the same arc. So coming off of the center, it intercepts the same arc. And what it says here, if I call this, angle 1 and angle 2, it says that the measure of angle 2 is half the measure of angle 1. Okay, so this, the inscribed angle is half that of the central angle, or vice versa. You could say that twice the measure of angle 2 would give you the measure of angle 1. So either one of those would work. Just multiply both sides by 2 or not. Excuse me. Then the measure of the inscribed angle, again, is half the measure of the central angle. So let's look at a couple of things that can happen from here. Let's say we have a circle. It has an inscribed quadrilateral. We don't know what that quadrilateral is yet, but we do know that it has an inscribed quadrilateral. So we're looking to find the measure of each of the angles in that quadrilateral. So let's start with x here. We're going to start with this angle down here. Again, it's half the measure of the central angle that intercepts the same arc. So let's first look, what does x intercept? Well, the angle x, if we trace the lines here, there's 1, there's 2, it intercepts this highlighted arc here, right? That's the arc that it intercepts, which has a measure of 150 degrees. So it has a measure of 150, which means the central angle has the same measure of 150 degrees. Right? The central angle and the arc have the exact same measure, which means x is half of 150. So let me just clean up this picture for you a little bit. We would say that x is half of 150, which turns out to be a 75-degree angle. So x is 75 degrees. We can do the same thing with z. Again, z intercepts this arc here, and the measure of that arc, again, is the 80 degrees here, plus the 90 degrees here, which is 170 degrees. So we can say, again, that z is half of 170, which is 85 degrees. Now, in order to find w or y, we first need to know what the measure of this arc here is, right? We don't have that measure yet, so we first need to figure that out. Well, we know that the arcs all add up to 360 degrees, so we have 3 of them. So to complete the circle, we would need to know that 80 plus 70 plus 90 plus whatever this missing arc is, we'll call it, call it A, plus A will have to add up to 360 degrees, right? So just, simple math here. We have 80 plus 70 is 150, plus 90 is 240. So we end up with A equals 120 degrees. So to solve this now, let me just again clean up this picture for you. So we know this is 120 over here, right? We know this is 120 right here. Sorry, 120 degrees. So if I want to find angle Y, let's say, let me get rid of this at the bottom. It's the same concept as before. We would say that Y is half of the, again, it intercepts this whole arc here. So this whole arc here is 70 plus 120, which is 90. So we would say that Y is half of 190, which ends up being 95 degrees. And we also know that W is half of 120 plus 90, right? W intercepts this whole arc here. What's 120 plus 90? That's 210, right? So W is half of 210. Which is 105 degrees. 105 degrees. So something that you can kind of gather from this, and this happened just in this specific case, but it also happens in general. It's a corollary to the theorem we just saw. If you notice the opposite angles in this inscribed quadrilateral, so let's look at angle Y and angle Z here, right? So let me actually use something besides a highlighter. If I want to look at angle Y and angle Z and the relationship thereof, well, angle Y is 95, angle Z is 85, and if you notice, Y plus Z gives you 180. Well, let's look at the other side. We have angle W and angle X, right? Those are opposites as well, and W is 105 plus X 75 also gives you 180. So one of the corollaries is that the opposite angles of an inscribed quadrilateral are supplementary. So again, the opposite angles of an inscribed quadrilateral are supplementary. So I highly encourage you to write that down. The opposite angles of an inscribed quadrilateral are supplementary. Okay, let's look at another example here. Alright, so let's look here. We have a circle with an inscribed angle forming a shape inside it is a triangle where the diameter of the circle, so again that's this segment here, right? The diameter of the circle is forming a triangle with that inscribed angle. So let's see what we can do here. Well, we know that I think the easiest one to solve for in this case would be x. So if we want to solve for x, again it says x is an inscribed angle. It's half of the arc that it intercepts. Well, it doesn't give you the measure here. I guess we need to find y first, don't we? Because we need to find that measure. So, well, that shouldn't be too bad. Y is just half of the circle, right? So half of 360 degrees, which means y is 180 degrees. So that's not too bad. So x then is half of that arc length because, again, the central angle that forms this arc is a 180 degree angle. So x is half of 180, which gives you 90 degrees, which means we actually have a right triangle here. And that's another corollary to the inscribed angle theorem, says that if an inscribed angle forms a semicircle, then that inscribed angle must be a right angle. So, or, excuse me, another way of looking at it, just any time you have an inscribed angle where it meets, it creates the diameter there, that inscribed angle is always going to be a right angle. Okay, so that adds a lot of problems that can be added to this. They can add trig problems because you're now dealing with right triangles. They can add 30, 60, 90, 45, 45, 90, etc. So you need to make sure you're up on your trig going into this lesson as well. So we have x and y. Now we need to find z. Well, in order to find z, we need to know what this arc is, because z is half of this arc, right? So again, if this arc here is 40, and this whole side adds up to 180, then this arc over here must be 140, which means z is half of 140, which is 70 degrees. Alright, let's move on to another one. So this is the last corollary. Again, we're going to show you through a problem what the corollary says. Well, if you notice, x and y are both inscribed angles, but they form the same arc, right? X forms this arc, as does y. So we could say that x is half of 80, which is 40. But we can also say that y is half of 80, which is also 40. And the corollary says that if two inscribed angles form the same arc here, then those two inscribed angles must be congruent. So we could have said at the beginning that x must be congruent to y. Or x must equal y, I should say, since they're measures. X must equal y. Okay? That one's a quick one. Quick corollary. Pretty self-explanatory. Alright, I'm going to continue the next... there's one more theorem that has a couple things attached to it. I'm going to continue that theorem on part 2 of this video. So that should be good. This video is basically all about the inscribed angles theorem, and the next one has to do with some tangents. So yay for that. I know you're excited when I say that. Alright guys, see you next part.